In this video we're going to look at rounding. Now when you're rounding a number, you can either round up to the next tens or round down to the original tens. So to give you an example, if I had a number that was 12, to its nearest 10, it's closer to the bottom, so it's closer to 10 than it is to 20. Now this happens the same regardless of whether we're rounding to the nearest number, or the nearest 10, the nearest 100, 1,000, million, or to the nearest decimal place. Now to help you figure out whether you're rounding up or rounding down, you can see quite easily that these numbers are all closer to that direction. And these numbers are all closer to that direction. 0 will stay where it is. And in order to keep things balanced, that means 5 will always go up. So, if we look at it for rounding decimal places, which is the one that you will be tested on most, rounding decimals, I'm going to give you a number here. It's a very long number. And we're going to round it to all its decimals. Well, most of them. So if we round it to one decimal place, we have 2 points. We want one number after the decimal place. But in order to figure out what that number would be, we need to look and see what number comes after it. The 8 comes after it. 8 makes it round up. So what we have here is 2.2 to one decimal place. We tend to write DP. You'll find that mathematicians use abbreviations a lot. Now if we try to 2 decimal places, 2.1, and this is where you see we're looking for here. So we're interested in what comes next, and that 5 will round up. So that turns that 8 into a 9. So the trick is always to look for the number after the one you need to round to and see how that will affect it. In the case of the next one, 2.18, and we know that this is a 3, so it's going to round down, which means it has no effect on the number in front of it. So we stay at 5. And we move on again. We're going to do 2.185, and are we doing 3 or 4? The 7 tells us it's rounding up, so the 3 becomes 4. We shall continue like that. So on our next one, we're looking here. We've got 2.1853, and the 7 is rounded up by that 9 to an 8. And we carry on, 2.1853 now. I'm not going to write the 7 here just now because we've got a 9, and 9s can be tricky. So I'm going to work out what happens to this next bit before I write it. So if you see a 9, be wary. So you could think of it as 79 here, and we're rounding it to the nearest number. The nearest number, 79, the 8 here, rounds it up, so 79 becomes 80. And that's to 6 decimal places. You'll see that 5 and 6 decimal places are actually the same number. And that's the quirk of the 9. And then if we carry on for the next one, we get 2.1853. And this time we're here. The 1 rounds down so that nothing changes here. So we go back to having 7, 9 and 8. And in the final one, we've got a 9 on the end here. So that's going to round this number to a 2. So all our other numbers as they were. That's 8 decimal places. So to recap, you're always looking for one number beyond the number you need, and if there is a 9 as your last number, be wary. The next thing we're going to look at is significant figures. It's very similar to rounding. Now, mathematicians being mathematicians, we tend to either shorten this to sig, fig, or SF. So you'll see them sometimes come up in questions. I don't want you being surprised at what they are. So it's similar to rounding in that we do still round, but we're actually writing in our digit value as well. So if, for example, we had 2379.82 and we were doing it to 3 significant figures, then what we would be looking for is the first 3 numbers and what the next one does to it. So what we would get there is 2380. We don't need anything after the decimal point because it's not significant to us. We don't care. We've rounded beyond it. And if I give us the example 1572908, we want it to 2 significant figures, then what we're looking for here is the first 2 numbers and we take account of the 1 after it. So again, the 7 will round us up and that will give us 16. But all these zeros matter because we still need to place hold for how far away the decimal point is. So we've got 1, 2, 3, 4, 5. Just check we've got the same number of numbers. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We're fine. You should always write your 2SF. I should have written there my 3SF. Right. You must never forget that these numbers are there. They count because they keep the distance to the decimal. So if we were to split it and see what this number is, you'd see it's rounded to 1.6 million or 1,600,000. Without these zeros, you could lose that value. The significant figures are another one that come up a lot in the exam. But the next thing is the one that they're going to test you on most, and that would be scientific notation. And this is a way of showing really big numbers and really small numbers in ways that are easier to manipulate. So we have scientific notation, and as you can guess, it is used in science. I forgot how to spell notation there. It's also called standard form. And it depends what technology you're in. If you're in science, it's probably going to be called standard form. If you're in engineering, it's probably going to be called scientific notation. But both terms are used interchangeably. So if we had that number we just had, one more, right? And we wrote it in standard form, we need to write it as a number between 1 and 9. So we would write this in standard form by putting a dot after our first number. Let's change colours here. And that changes the value, so we need to write an addition to that. So we would write it as 1.6 times 10, and then how far have we moved our decimal place? 1, 2, 3, 4, 5, 6 places. So it's times 10 to the power 6. Now if you have a Casio calculator and some of the other brands, they will actually have a button that has times 10 to the n or similar language on it. This is the button you will use in the calculator exam to make your life easier. So if your calculator has that button, please get used to using it for these questions. If it doesn't, I will show you in class how to get your calculator to work on these specific style of questions. So what we're looking for is a number that's always between 1 and 9. Everything afterwards still counts. So unlike rounding and scientific and significant figures, the numbers afterwards still count. They don't get rounded away. So if we had, let's see, 1.57298, like we did the last time, the original number we were using for significant figures. So our original number was that, and in scientific notation, it's this. But to two significant figures, it's this. They tend to combine these questions a lot, so you need to be very careful reading the question of what it is it's asked for. So to give you another example, if we have 2379.80 and we're wanting to change that into scientific notation, we're going to need our point to be here. So we're going to have 2.3798, we don't need the last zero, and we are going to multiply that by 10 to the how far has the decimal moved. The decimal was here, it's gone 1, 2, 3 places. So it's times 10 to the power 3. Big numbers always move us by a positive power. So if you imagine, let me just write positive before I forget how to spell it. If you imagine that you were looking at some astronomical data, something looking at stars that are millions and millions of light years away. It's easier to write it in standard form and scientific notation than it is to write out the whole big number repeatedly time after time. The same with small numbers. So in biology, for example, you could be looking at the size of an electron within an atom. It might be tiny. One example I've got is the probability. So I'll give you a little bit of maths notation here. The probability of a lightning strike. Specifically, the probability of a lightning strike hitting a person and causing a heart attack, because this information was from the American Heart Association. And that is 0.41234 11,919. So that's the chances, and that's a percentage, the chances of you being hit by lightning in America and having a heart attack as a result. Now that's a very, very small percent, but we would be writing that in scientific notation. So we're looking at how far this decimal point moves. It's gone 1, 2, 3, 4, 5 places to get to its first number. So we would write that as 1.1919 times 10, and if you remember that was 5 places, so 10 to the power 5. But because we're going smaller instead of bigger, it's the minus 5. So small numbers are a minus power, a negative power. That's a rubbish W. I apologise for that. Right. Now you will find that for positive, I will generally write that, and for negative, I will generally write that. So if you come across these, they're not something weird. They're just positive and negative in shorthand. And that's scientific notation.